everyone. Welcome you all to today's class. So today's class is very simple. We are going to take one of the very simple activity and we will be demonstrating that in our class. So let's begin it. So which activity we are going to take. So so this is the activity we are going to start. So to verify, to demonstrate angle in a semicircle is a right angle using vector method. Yes. Okay, so this is your activity number 5. Let's begin it. The objective of today's activity, just let me switch off the video panel. You can get the full. Okay, so here you can see objective of the activity is to verify that angle in a semicircle is a right angle using vector method. And for this we need what? So in case you are demonstrating this, offline, you can use you can use white paper sheet, pencil, scale, compass for drawing a circle. Okay. And in case you are demonstrating the activity online, if you want to make the activity paperless, so you need some online tools like Google Slide, PPT, or you to draw the circle you can use GeoGebra, GeoGebra or some other geometric tools so that you can draw the circle. And what is the procedure for doing it? The procedure here what I have written here, method of construction, or you can say the procedure of doing this is, so first of all we can take one circle. We have to draw a circle, and just one moment. Yeah. So the way it is written, I will be drawing here, but in the next slide I am showing this. Maybe I can show you there. Draw a circle with center O and radius 4 centimeter. Or you can take a circle of any radius. Okay. Now join O to A, B, P, Q and A to Q, B to P. So let me show this. Otherwise, without, showing this, if I say join this, okay. Yeah, so here is the circle. So draw the circle with center O. Okay, so this is A, B, then P and Q. Let me use the pointer here. Yeah. So here you see A, B, P, Q, 4 points. Now what you can observe here, O is, I've taken it as origin. So it means you are having OB, OA. So we are joining OA, OB, OP and OQ. Right? So it means you are getting OA, position vector of A, OB, position vector of B, OP and OQ, position vectors of P and Q respectively. And let us take the radius of the circle as R. Or I may write here, OB vector is R vector. So OA will be, vector OA will be minus R vector, because OB and OA, they are in opposite direction. So let us take position vector of P as P vector, right? OP vector equal to P vector and OQ vector is Q vector. Okay, so is it clear? So now just let me go to the previous slide. Yeah. So what we have to follow these 4 steps. So first, drawing the circle with center O and radius of any measurement of your choice. Draw O to A, B, P, Q and A to Q and B to P. Right? Let us take length of OA R. So OB equal to R, OP equal to P, and OQ equal to Q. Okay, it means OA vector is minus R vector because we are taking OB vector as R vector. And let us take OP vector as P vector, OQ as Q vector. Okay, so it's very simple activity. So now consider triangle OAP. So in triangle OAP, this is OAP. So we have OA plus AP equal to OP vector, right? So OA minus R plus AP vector equal to P vector. So it means AP vector is P vector plus R vector. Similarly, if you take triangle OBP, okay, this is OBP. So here you can see OB plus BP equal to OP. So it means R vector plus BP vector equal to P vector, which gives us BP vector equal to P minus R. Then next coming to triangle OBQ, OBQ. So here you can see OB plus BQ equal to OQ. So that is using triangle of vector addition. So OB vector is R vector plus BQ equal to Q. So BQ vector is Q minus R. And finally taking triangle OAQ. So in OAQ triangle, OA plus AQ, that is equal to OQ. OA equal to minus R vector plus AQ vector equal to Q vector. Okay, OQ vector is Q vector. It means AQ vector is Q minus, Q plus R. Is clear? That means we are getting AP vector equal to P plus R, BP vector is P minus R, BQ vector is Q minus R, and AQ vector is Q plus R. Clear? So in next step what we are going to do, so we have to verify angle in a semicircle is a right angle. Means angle APB is 90 degree. Similarly, angle AQB equal to 90 degree. These two cases we are showing. Okay. So angle APB equal to 90 degree means AP vector and BP vector, they should be perpendicular to each other. Similarly, in second case, whenever you take AQB triangle, then angle AQB 90 degree because this is angle in, in the semicircle, these two are APB and AQB. These are angles in semicircle, right? So in second case, if you take AQB angle 90 degree, it means AQ vector should be perpendicular to BQ vector. And you know, if two vectors are perpendicular, the dot product is 0. Okay, so just note down AP vector is P plus R, BP vector is P minus R, BQ vector Q minus R, and AQ vector is Q plus R. Now what is our observation? We have taken two cases, as I said, triangle APB and triangle ABQ. Okay, so now AP dot, yes, AP dot BP equal to, we have taken AP vector equal to P plus R, right? BP vector is P minus R. So AP dot BP equal to P plus R dot P minus R, which is magnitude of P ka square minus magnitude of R ka square, right? So but you know P vector, magnitude of P equal to magnitude of R, because OP and OA, OP, OA, OB, OQ, all these are radii of the same circle. So that's why vector P, magnitude of vector P equal to magnitude of vector R. Okay, so magnitude of P square minus magnitude of R square equal to 0. It means we are getting AP dot BP equal to 0, which implies AP perpendicular to BP. It means angle APB equal to 90 degree. Right? So angle in a semicircle is a right angle. Okay, now second case also we can just demonstrate. Yeah, we can see second case. We have taken triangle ABQ. We have taken BQ and AQ. Okay, one is Q minus R, the other one is Q plus R. When you take the dot product, here also we are getting magnitude of Q square minus square of R square. And magnitude of P equal to magnitude of Q equal to magnitude of R. So Q magnitude of Q equal to magnitude of R, that is radius of the circle. So we are getting this BQ dot AQ equal to 0. It means BQ perpendicular to AQ. So angle AQB equal to 90 degree. Okay, so from these two cases we can conclude angle in a semicircle is a right angle. Okay, so after, this is basically we have verified the, the concept, verify the statement by using vector method. Okay, and which other cases we can apply this concept. So this concept, yeah, this activity can be used to find angle between two vectors also. Okay, here we have proved angle in a semicircle equal to 90 degree at the right angle, but this activity can also be extended to find angle between two vectors. So thank you so much.